Well, good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by AWS and Kong. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting program and demo ahead, but before we get things rolling, I do have just a couple of housekeeping notes I'd like to review. First of all, we are recording today's session. So if you happen to miss any of our discussion, if you'd like to rewatch at a later time, or of course share with your team, you will be receiving an email with a link to access the recording on demand. You'll be getting that email shortly after we conclude this live session today. Now, there are a couple of ways for you to engage with us. The first and the easiest way is the chat tab. So I see we've got some people checking in from India, Texas, and Sweden, all over the place. So if you see that chat tab, let us know from where in the world you are joining. If you have any specific questions, we do want you to direct those to the Q&A tab, as sending your questions to the Q&A tab just helps us keep track, and we want to make sure no questions go unanswered. So be sure to send those in when you have them, and we'll do our best to address them. Additionally, before we close things out today, we are giving away 2 $25 Amazon gift cards, so be sure to stick around to see if you're one of our lucky winners. And we also have a couple of additional resources in the handout section, so feel free to grab those today. So our topic is scaling API security design patterns with Kong and AWS. And I'm joined again today by Anuj Sharma, Solutions Architect at AWS, and Claudio Acquaviva, Software Architect at Kong. So Anuj, Claudio, welcome back. Thank you both so much for joining us today. Anuj, do you want to go ahead and get our conversation started?
Absolutely. Thank you so much, Colby. And good morning, good evening, and welcome to the webinar where we talk about scaling the security design patterns using Kong on AWS. I'm Anuj, and I'm a Principal Solutions Architect here at Amazon Web Services. I'm also joined with me with Claudio from Kong. Claudio, if you want to quickly say hi and introduce yourself.
Yeah, sure, absolutely. Claudio Acquaviva speaking here. I'm speaking from São Paulo City, Brazil. I'm solution architect here at Kong for 5 years now, a little longer than this. AWS ambassador as well. Pleasure talking to you all.
Thank you so much, Claudio. Claudio will be taking us through the second section of the webinar, so hang on to that section. Awesome. So in today's session, we will go over the implementation details for the core design principles defined in the security pillar to see how Kong Gateway as a workload on AWS scales well from a security standpoint. We want to ensure that our customers take advantage of the services we provide to protect data and assets so that they can minimize the risk exposure to their businesses and concentrate on providing great services for the customer as a result. With that in mind, in today's session, we will see how to leverage the services from AWS to seamlessly scale security and APIs for Kong Gateway on AWS. To level set, the core principles defined in the security pillar that should be evaluated whenever you design an application begins with implementing a strong identity foundation based on the least privilege principle and enforcing separation of duties with appropriate authorization for each interaction with your AWS resource. It also aims at centralizing identity management and aims to eliminate reliance on long-term static credentials. Secondly, enabling traceability at all layers helps you monitor, alert, and audit actions and changes to your environment in real time by integrating log and metric collection and traces with systems to automatically integrate and take actions. Thirdly, consider applying defense in depth approach with multiple security layers or multiple security controls at all the layers. For example, it could be the edge network, it could be the VPC, it could be load balancing, it could be the compute layer, it could be the operating system layer, or it could be the application layer, or even your code. Also consider implementing software-based security mechanisms to improve your ability to securely scale more rapidly and cost effectively by defining and managing the control as a code and version control them in the source code. And lastly, protect and encrypt your data in transit as well as in rest. Now we will go to the implementation details of all these security design principles in depth today. But before we start with the first one, let me give a quick overview of Konnect platform. Now, Konnect is a unified API management platform that reduces operational complexity, promotes federated governance at scale, and delivers end-to-end API lifecycle management across a variety of protocols or even compute architectures, let it be EKS or ECS or EC2 or even Red Hat OpenShift on AWS. From top down, there are 4 different layers as we see in this specific architecture. The first layer, which is referred as Konnect applications, comprises of API products, analytics, dev portal, and service hub. API product bundles and manages multiple services. Each API product consists of at least one API product version, and each API product version is connected to a gateway service. You can document your services and publish API products to a developer portal for consumption. Now, developer portal, on the other hand, is a customizable website for developers to locate, access, and consume API services. The dev portal enables developers to search, browse, and navigate through the API documentation, test API endpoints, and manage the credentials at your own cadence. Konnect offers a flexible deployment option to support both internal and external APIs. Now, API analytics lets you monitor the health and performance of any API product, route, or an application which is managed by Konnect. The next layer is the Konnect platform itself, which comprises of gateway manager, authentication, authorization, or specifically role-based authorization, audit logging, or multiple geo support. The gateway manager in specific is a Konnect functionality module that lets you catalog, connect to, and monitor the status of all the control planes and data plane nodes all in one place and manage control plane configuration. Now, the gateway manager and the Konnect application as a whole does not have any access or visibility to the data which is flowing to your data plane nodes, and it does not store any data other than the state and the connection details of each node, which means that the actual API traffic, or in other words, the consumer traffic of your APIs flows directly to the data plane nodes via, it could be an AWS load balancer that you manage in your own AWS accounts. And you as a customer can deploy and manage the data plane node on a variety of compute platform. It could be EKS, EKS Anywhere, ECS, or even EC2. Now, we have 5 different principles to talk about the implementation details for, and roughly around 45 minutes or so. So let's get started with the first one, which is implementing a strong identity foundation. The use case which warrants us to implement a strong identity foundation is the authentication and authorization request for your API traffic sent to Kong Gateway. It could be in a form of basic auth or OAuth or key auth or even MTLS. Irrespective of the choice of mechanism, which is typically implemented by Kong plugins calling AWS services, the communication between Kong pods and the AWS service by itself is authorized based on the principles of least privilege using IAM roles for service accounts, commonly referred as IRSA. Now, let's double click on IRSA setup a bit. You start by creating an OpenID OIDC provider in AWS Identity and Access Management and point to the EKS clusters OIDC provider URL. You then annotate the service account with the AWS role ARN. The role needs to be configured to trust the federated principle of cluster-specific OIDC provider for assume role with web identity STS action. Any specific API action that the application running in your pod may need to access need to be defined in a IAM policy that you attach to this specific role. And now, when you create a service account in EKS in this way, it also creates a service account token. This service account token is stored as a Kubernetes secret in the same namespace. Now, this token is nothing but a JSON web token, commonly referred as JWT. Now, when the pod, which is configured to use this specific service account, when it's configured to use this specific service account, and when it starts up, the mutating web admission controller calls the EKS pod identity webhook, which then mounts the service account JWT as a volume and injects few environment variables in the pod. These environment variables points to the location of the mounted token file and IAM role ARN corresponding to the service account. The AWS SDK that runs with your application inside the pod looks up these environment variables for config and sends a request to AWS STS requesting to assume this specific IAM role. It also sends the service account JWT in that request. Now, the AWS STS uses the trust relation for the specific IAM role, which points to the cluster's OIDC provider endpoint to ensure that the presented service account JWT is valid and issued by the trusted cluster's OIDC provider. And it also ensures that the service account is actually trusted to assume the specific IAM role. Now, STS will then issue the temporary security credentials for the IAM role and the application which is running in your pod can then use these temporary credentials to access the AWS resources. When you implement IRSA, you avoid privilege escalation by consuming multiple pods running in the same cluster. Don't assume the EC2 instance role and AWS services, which they should not have access to. Next, consider implementing Kong's OpenID plugin, which can be used to implement Kong as a proxying OAuth resource server or OpenID Connect relaying party between the client and the upstream service. Using this plugin, you can implement signed JWTs, opaque access tokens, refresh tokens, username and passwords, client credentials, or even session tokens for that matter as a grant and credentials. The plugin works well with Amazon Cognito or AWS directory service as a backend identity provider. Once you create a pool as an example, you receive the output of the pool ID, client ID, issuer URL, client secret, which you can then refer in the Kong ingress controller CRD as an example for configuring the OpenID Connect plugin. We will discuss just in a bit in the later part of the session how you would actually securely mount any secret to the EKS cluster. All right, next step, which is enabling traceability at all levels. Now, first, logs needs to be collected from the EC2 instance and the container instance at which the Kong control plane or the data plane are running. This includes tailing stdio logs from various pods, collecting syslogs, kubelet logs, kube proxy service logs, or even Docker service logs. You can use FluentBit daemon set to instrument log collection. For your convenience, we have created a sample FluentBit configuration for you to quickly get started. The sample sends the output to a Kinesis stream, which can further be fronted to sync the logs to a third-party observability provider of your choice. You can obviously modify the output section in this configuration to ship the logs to AWS CloudWatch logs instead if required. Next, in order to instrument the log collection from incoming API request and going to upstream service via Kong gateway, Kong logging plugin can be used. These plugins, when installed, log the request and response for each API request to a file or to a TCP server, or to an HTTP server, UDP server, or directly shipped to a third-party observability provider of your choice. The log hence collected includes the request property about the request which is sent by the client, response properties about the response which is sent back to the client, routing information, authentication and authorization details, latencies at various touch points, client IPs, or even success or failure codes, or tries or retries for the specific request. Here is a sample CRD, which can be enabled globally to sync these logs to stdio as an example. Now, for logging the actions that Kong pod may be taking to call AWS services by assuming IAM role for service account, enable AWS CloudTrail in that account. Example of such call include Kong pod calling AWS Secrets Manager to retrieve RDS credentials, or license keys, or even API keys for each consumer. Consider sending the audit trail logs for the admin API actions from the self-hosted Kong Gateway installation to AWS CloudTrail Lake. You will need to enable this integration from AWS CloudTrail Lake and install a specific Lambda function to ingest the logs from Kong Gateway to AWS CloudTrail Lake. For detailed step-by-step, we encourage you to follow this link or scan this QR code. This lets you consolidate, immutably store, search, and analyze activity events from AWS and Kong all at one place, consolidated at AWS CloudTrail Lake. Very similarly, from Kong Konnect UI, you can enable the logging for authentication event, authorization events, and access events to Konnect API. Konnect delivers log events in CEF format or JSON format. You may specify which format to choose in the audit log when you configure the audit log webhook endpoint. Webhook calls include a batch of event. Each event is formatted with either CEF or JSON and separated by a new line character. Next up, consider enabling EKS control plane logs, which includes Kubernetes API server log, Kubernetes API logs, audit logs, authenticator logs, scheduler logs, and controller manager logs to CloudWatch. You can enable AWS Guard Duty for automated cluster threat monitoring, which will use the Kubernetes control plane audit logs feed combined with threat intelligence feed, such as malicious, a list of malicious IPs or domains, and machine learning on top to identify unexpected, potentially unauthorized, and malicious activity within your AWS account. In Guard Duty, you get a drill down view of a cluster specific, deployment specific, pod specific, or even container specific metadata to pinpoint to the threat. Additionally, enable Amazon Detective integration with Guard Duty, which will provide a set of linked contextual data, which will help you to conduct faster and more effective investigations. Consider consolidating all the findings from Guard Duty and Detective in a single AWS account so that your security operations team have the visibility to the threats to either take actions or if required, or even for forensic purposes. Now, next up, automating security practices. Now, with the adoption of Kubernetes and EKS comes the next set of challenges, which are typically, how do you do cluster management, workload management, team management, related policy management. Now, CNCF has a large ecosystem of toolsets to choose from. So how should you go about configuring or installing these tools, configuring these tools, managing the dependency, and a lot of other day-to-day operational needs, which, if not done correctly, would leave holes in your system. To solve this conundrum, Amazon EKS Blueprints was created. EKS Blueprints helps you configure complete EKS cluster that are fully bootstrapped with the operational software that is needed to deploy and operate workloads. You can describe the configuration of the desired state of your EKS cluster, such as the control plane, worker pair nodes, and EKS add-on as infrastructure as a code blueprint. Once a blueprint is configured, you can use it to deploy consistent environments across multiple AWS accounts and regions using continuous deployment automations. EKS Blueprints builds on an existing work from EKS open source community, including the use of Terraform AWS EKS module for cluster provisioning. And now we extended the EKS Terraform blueprints further and partnered with Kong to build blueprints for Kong, which lets you quickly provision Kong Konnect data plane instances on EKS, all with the surrounding ecosystem of CNCF tools, all within minutes. Complementing to these blueprints, we also published use case driven samples, which have been scanned to find any misconfigurations and even address those misconfigurations before even they are deployed. We encourage you to try out these samples and let us know if you'd like to see any additional use case or purpose-built use case, and we'll be happy to work with you to create an add-on to these samples as an example. Feel free to scan this QR code or follow this link which will take you to the use case-driven samples. With this, I would like to invite my friend Claudio to talk about the implementation details for the remaining two design principles and also take us through an awesome demo.
Thank you.
Over to you, Claudio.
Thank you. Yeah, let me share my screen now. So yeah, for this next session, I'm going to cover security in all layers of network application. In other words, I'm going to explore some topologies for a common, very, very common Kong gateway deployments. So again, every time you go through you jump to a Kong gateway deployment, regardless if you're going to use our control plane running locally, self-managed running locally, or our control plane offered as a SaaS, you got to go through these specific topics. You got to show how the control plane and data plane should be reached. So you got to manage the load balancers, regardless what kind of load balancer you're going to deploy. Could be network load balancer, could be application load balancer, and so on and so on. The other thing, how to manage, how to play with firewalls. As you know, the API gateway will be responsible for some use cases, some security use cases. That does not mean you don't need a WAF. As a matter of fact, WAF will be there taking care of other use cases. As a matter of fact, I'm going to show in my demo in a moment how Kong API Gateway data plane, more precisely, can work along with the AWS WAF. And then again, data plane will be responsible for some use cases, WAF will be responsible for other use cases. And then again, I'm going to talk a little bit about some specific plugins on it to implement mutual TLS all over for all connections you're going to have. So, in very, very high level diagram here, you have your data plane and control plane deployed in EKS. Again, this diagram is based on your self-managed deployment. I'm not using Konnect, which is the SaaS version of a control plane. Both control planes and data planes, they have been deployed in my EKS cluster. From the Kubernetes perspective, there are two deployments, one for the control plane, the second one for data plane. As a matter of fact, you can deploy data planes as many times as you want. That's the beauty of the CPDP separation, the control plane, data plane separation. You deploy control plane once, and then data plane as many times as you want, in order to protect the specific workloads you have locally in these Kubernetes cluster or any other environment, including ECS, including EC2s, plus auto scaling group, including other EKS clusters and so on. But then again, from the reachability perspective, you got to solve the two main traffics. The traffic coming from the administrators, they want to create new APIs, policies, change policy to take care of the API life cycle. And then the second kind of traffic, I would say, like from the performance perspective, the most important one, the massive collection requests coming from the API consumers. So again, that will be great to get these two traffic support, of course, like some load balancer taking care of one traffic number one, the second. Oops, I hope you can still see my screen now. Yeah. So again, here's the basic topology considering public APIs. So again, down here in my private subnet, you can see the two Kubernetes deployments. The first one, the control plane, as I said, is a deployment number one. This deployment number two, that's where the data planes are. So again, the consumers, they're going to consume the data planes. They're not really allowed to create new APIs. This is a part of the admin role to create APIs, apply policies, and so on and so on. So again, as a good reference, that would be great to have two load balancers, one running deployed in your public subnet to expose the data planes to the API consumers. And the second one will be deployed in your private subnet because only admin should be able to hit this load balancer, and then of course the control plane sitting behind it. So that's a kind of very, very basic deployment, two load balancers, one for the control plane, the second for data plane, and then again the data plane, the load balancer deploy for data plane is going to be in your public subnet. As I said before, Kong supports any AWS load balancer, including even classic load balancer, if you will. Our recommendation is to run network load balancer because, again, for specific performance capabilities and so on. So again, the two main users of the gateway, admins hitting the load balancer to create APIs, consumers hitting the second load balancer in order to consume the APIs being exposed by the data planes. So again, for private APIs, the APIs provided by the control plane should be private. In other words, the API consumers, they should never, ever hit the load balancer because again, they have been deployed in private subnet. And then again, that's the way you can protect the control plane from the API consumers. Again, it's going to be exposed only for our administrators and developers, assuming that these specific developers, they have access to this control plane as well. So what happens when you have both public APIs and private APIs? In other words, you have some consumers outside consuming again the load balance you got in a public network, a public subnet, but at the same time you might have some internal consumers. Again, the internal consumer should be able not just to consume the APIs, but consuming APIs internally, in a trusted location you got in your organization. So again, this load balancer over here, that would be great to have a specific load balancer for the consumers. Again, private subnets, a load balancer for administrators, a second load balancer for the API consumers, for internal API consumers. And then again, this load balancer remains the same, like exposing the data planes to the external API consumers. What happens to the WAF? WAF is very, very important, especially when we come to data plane. So data plane, again, is responsible for handling a massive collection of requests coming from the API consumers. But then again, as I said before, data plane won't be alone. Like, working along with data plane, you should have a WAF. As you know, AWS provides a very, very important web application firewall implementation in order to, again, to take care of, to control specific use cases, including OWASP, sequencing, denial of service, and so on and so on. Again, I'm going to show very, very basic use case where I have the AWS WAF and Kong data plane playing together. in my demo session in a moment. So besides these, the several topology options, very, very important to address the specific use cases. There's a kind of use cases you should implement using the API gateway. So again, Kong out of the box provides natively extensive list of plugins. Each plugin is responsible for a specific processing. So we provide, for instance, plugins related to authentication. Therefore, you can implement all sort of authentication mechanisms. For instance, LDAP-based, OIDC-based, and by the way, my demo environment, I'm going to show Kong data plane playing along with Cognito in order to implement OIDC-based authentication process. Besides authentication, Kong provides other plugins as well, responsible for other kinds of processing. For instance, rate limiting, very, very important to protect not just the gateway. The gateway, as a matter of fact, is not so important, but the applications sitting behind the gateway. So you got to protect them. So you are able to do it using the rate limiting plugins we provide. Not just rate limiting, but again, you can limit the size of the request you are receiving from the external consumers as well. API restrictions, for those familiar with WAF, quite similar to the policies you usually implement in your WAF infrastructure, like in order to define white lists and black lists for your for IP addresses the external consumers are using. Bot detections, another plugin we also provide in order to detect specific behaviors, bot behaviors that therefore limit or disallow this bot communication with the application sitting behind the gateway. Proxy caching, in order, again, not exactly, it's related to security because, again, once you're going to cache the data coming from the upstream, somehow you are protecting your application sitting behind the gateway because, again, the gateway will be responsible for respond to the consumers without hitting the upstream sitting behind the gateway. And then, of course, the third-party WAFs. Again, I'm going to show AWS WAF and Kong data plane playing together in a moment. Besides all these plugins, please, if you are interested about these plugins, please check the Kong documentation. Going to see again extensive list of plugins we provide. Plugins to integrate your graphical web servers, for instance, AWS AppSync, Amazon Kafka service, for instance, another plugin we also provide to integrate the Kafka service provided by AWS, and the list goes on and on and on. It's a very, very important, extensive list, as I said before. So this section, now I'm going to talk a little bit about data protection at rest and in transit. So again, very, very important topic, like, not just to protect the infrastructure, the gateway and the applications sitting behind the gateway, but now we're talking about the data you're going to store. And then every time we talk about this, very, very important to have some specific technologies to take care of the data protection at rest and, again, in transit. So the consumers, they're going to talk to with data planes, they're going to talk to your upstreams, your applications, and so on and so on. That will be reasonable to have security mechanisms to protect these communications as well. So the first topic I like to explore a little bit, it's what we call the data protection REST implemented the envelope encryption capability. Envelope encryption means that you're going to use a key to encrypt another key. So when we come to AWS KMS, we come to this notion of CMK, which is the consumer master key. So you can define your CMK, and then you can use this key to encrypt other keys. For instance, the DAK, data encryption key, you use a specific for each one of the secrets you're going to define along the way. So the flow goes like this. Every time you create a new secret using kubectl, of course, you have already configured the Kubernetes, your EKS cluster, in order to integrate the KMS. In other words, you have injected the CMK key to your EKS cluster. And then the API, the EKS API server is going to generate a DEK specific for the secret you just created. And then you're going to encrypt the secret with this DEK. Encrypts the step number 3, the API server is going to encrypt the DKA itself with the CMK. That's where the envelope encryption is. So you're going to encrypt the DE key with the CMK. One key getting encrypted by a second key. The CMK is going to be used to encrypt the DE key. Encaches the encrypted result in the API. Oops, I'm sorry. I'm going to cache the encrypted DEK. So, and then the step number 4, the Kubernetes app server is going to store the secret now encrypted with DEK inside the etcd. That's a step number 4. Last but not least, if you want to use the secret later on, the reverse process is going to take place. So the API server is going to read the secret encrypted with the DEK and then decrypted with the exactly the same DEK in order to present the secret for you. So the applications can consume the secret as well. So these flows over here is to support every time you create a secret using kubectl, all the secrets will be encrypted with a specific key. So one key per secret. So the second flow I like to explore is the secret is the flow when we usually implement for secrets for volumes. You're going to have your Kubernetes deployments. So again, this is implemented by the secret store CSI driver. Driver is one example of use of CSI driver. The secret is specific for secrets, as you can imagine. And then the secret is going to leverage the AWS Secrets Manager. In order to do it, secrets store CSI driver and the provider, they're going to leverage exactly the same ARSA infrastructure Anuj or model Anuj described previously. So ARSA, one more time, ARSA is a very, very critical, important model to get your Kubernetes cluster, more precisely some pods, consuming AWS services running, of course, outside of Kubernetes cluster. That's the case not just for the secrets manager, but for any other AWS service you want to consume in your Kubernetes pods. Wouldn't be different for Kong deployments. So Kong, as a matter of fact, what we want to achieve is the Kong deployment should rely on the secret store CSI driver, therefore AWS Secrets Manager, to take care of the secrets you're going to define specific for the Kong deployment. So that's the flow I'm describing here. So step number 1, you're going to deploy Kong. Doesn't matter if it's going to be the CP, the control plane, or the DP, of course. CP when we come to these self-managed kind of deployment. So every time you run a Kong deployment, you will have some volumes defined there to map specific, for instance, some examples here. So the digital certificate and private key pair, you got to use in order to get these two guys talking to each other, the control plane and data plane. They're going to talk to each other over a mutual TLS connection. In order to do it, you have to have a pair, digital certificate key and digital certificate and private key in order to get this connection in place. The thing is, you're going to externalize this pair using the secret manager. And then you have to have something in the middle to map the pair you have stored in secrets manager to the Kong deployment. The something in the middle, that's the secret store CSI driver. As a matter of fact, at the end of the day, the secrets store CSI driver is abstracting the secrets manager from the Kong deployment perspective. That's the thing. So step number 1, you're going to apply a manifest YAML file for a Kong control plane data plane deployment. And then these manifest has got is defining some volumes for instance, to consume the private key and digital certificate pair in order to have these two guys talking to each other. The pod creation is going to call behind the scenes, is going to call the secret store CSI driver in order to consume these the pair you have previously injected inside the secrets manager. So the CSI driver is going to map secrets manager, going to abstract the secrets from the con deployment, and then the con deployment is going to use the volumes. It's describing the manifest as it was local. As a matter of fact, again, the secrets store CSI driver is abstracting the secrets manager from the con deployment. Very, very important. Again, it's a very, very important best practice to externalize your secrets to somebody else. In our case, from con deployment perspective, this somebody else is the secrets manager, AWS secrets manager. Last but not least, data protection transit. Kong implements mutual TLS all over. Basically, we got three main traffics or communications. That would be better term for that. So three main communications. So we got the communication number one, where you got the control plane, data plane talking to each other. Every time you create an API,
I hope you can. So again, the very first communication point you have is the hello.
We've got you back, Claudio.
Yeah, you're back.
Okay, I hope you can hear me now.
Yes, we can.
Thank you, participant number 13. Thanks so very much. So again, the first communication we have is the one we got with the control plane data plane. So again, every time you create an API, you go to the control plane as an admin, of course, and then the control plane is going to publish this API to the data planes. This communication will be based on mutual TLS communication, and then you have to have a digital certificate private key exchange in order to build this tunnel. Therefore, the control plane, data plane, they can talk to each other. The second communication is the incoming traffic. So again, the data planes will be there exposing the APIs you have created, and then the consumers, they're going to send requests in order to consume the APIs. Therefore, these APIs are going to be routed to your upstream services sitting behind the gateway, and so on and so on. So this communication over here should be also based on mutual TLS. In other words, the API consumer should send these requests over a SSL tunnel, more than that, a mutual TLS tunnel built again with the data plane and the API consumer. So don't get confused with the mutual TLS you got with the control plane. So this time you got two mutual TLS connections, one from the data plane perspective, one with the control plane, the other one with your consumers. As you can imagine, the client certificate the consumer is going to present can be used not just to build a mutual TLS tunnel, but also to authenticate the consumer using, again, the client certificate the consumer presented. And then again, once you have authenticated the consumer, you can apply specific policies to it. So again, the mutual TLS, this second communication is very, very useful, not just to get these encrypted tunnel in place, but also to authenticate the API consumer sending requests to the data planes. The third communication we have, that's the the basic one. Like every time the data plane routes a request to your application, to your upstream services, this communication should also be based on mutual TLS. Therefore, in this sense, the data plane is going to be play the client role this time. So again, one more time, the client's digital certificate and private key. You're going to have exchange of these two pairs, data planes and your upstream services this time. And then again, you're going to have a third mutual TLS tunnel in place. Again, 3 different tunnels at the same time. One with the control plane, the second with the consumers, the third with your upstreams. So highly, highly recommended to implement these mutual TLS tunnels, all communications you got in your data plane infrastructure. So I think that's it. Yes. So no more slides. So again, I'm going to use my final minutes here to run a quick demo. Here's the topology, my demo environment. This time I'm going to use Konnect. Again, Konnect is our SaaS version of our control plane. It's a SaaS version of control plane. So I'm going to open the control plane GUI in order to show you the APIs and policies I have defined. And then this control plane is got one data plane deployed in an EKS cluster, as you can imagine, of course. So here's my data plane connected to the Konnect control plane. Not just with that, the data plane is being exposed to my API consumers through a application load balancer because I want to have a WAF, the AWS WAF, sitting in front of it. So again, the request is going through the WAF. The WAF is going to route the request to the application load balancer. The application load balancer is going to consume the node port of my Kubernetes con data plane deployment. More than that, the data plane, I got some APIs where I have the OIDC-based authentication process. In other words, these external API consumers should send a request to consume this specific API with, and is going to be authenticated by Cognito this time. If Cognito doesn't authenticate the consumer won't be able to consume the upstream service. Last but not least, data plane has a full-time connection with CloudWatch. So I'm going to see the CloudWatch landing page and my dashboards where the main metrics the data plane exposes or defines and exposes to the CloudWatch. And then I think that's it. So here we go. So first of all, here's my control plane. So as I said, this is my Konnect control plane GUI. As I said, the control plane has got only one data plane in place. I'm going to scale out this deployment later on just to see two data plane instances connected to the Konnect control plane. But this time, just to make my life easier, I've got only one data plane running my Kubernetes cluster. This data plane, again, is connected to my control plane. As a matter of fact, this is my pod ID. You can check it out. Here's my K9. You can check it out, my pod over here, running my Kubernetes cluster. This F4Z2, exactly my F4Z2 instance connected to my Konnect control plane. Other than this, I got some APIs defined. I got a very simple one, a service one based on this. The HTTP bin service is an echo service. Like, I'm going to send a request. It's going to reply with exactly the same data it receives from the request. So I got a route defined inside of it. The route is got some plugins defined. One rate limiting. I'm going to disable this one just to get a nicer test. First of all, I got some process running in the background, injecting some requests to my data plane so we can see some activities in CloudWatch. I'm going to stop them. So I just got the OIDC plugin enabled. I got two plugins enabled, but only configured, but only OIDC is enabled this time. So what happens if I try to consume this route HTTP route. So in order to consume this route, I'm going to use Insomnia, which is our API designer tool. So here's my request. I'm going to send a request to my data plane. Here's the route, and then I'm going to send a /get just to get a more specific response. So what happens if I send a request to it? So far, so good. I got a 200, meaning that I was able to consume this API. But if you remember the API, the route, as a matter of fact, is got the OIDC plugin enabled to it, meaning that I should have somewhere I should have OIDC credentials. And if you check my request over here, here's my Cognito credentials. As a matter of fact, here's my Cognito infrastructure. So here's my Cognito infrastructure. And then my client ID, for instance, you can check my client IDs over here. Exactly the same client ID I'm using to consume this API. Of course, if I send a wrong credential, I'm going to get a 401 as expected. So here's my client ID again. I'm able to consume it. So, and more than that, if you jump to CloudWatch, as I said before, I had some process running in background, injecting some requests to the data plane. That's why we're seeing some activities here. But again, data plane's got a full-time connection with the CloudWatch, and then you can see some metrics I have chosen for my dashboard. So all 401s responses, all 200s responses, all 429 responses, the request count, all the requests that have been injected to the data plane, and so on and so on. So again, there is a full-time connection with the CloudWatch infrastructure. What else? What happens with the WAF? So again, I'm sending exactly the same request, but not sure if you can see now. I have included a specific argument, which is kind of dangerous. So if you check our request, this time I got a specific user ID with a specific value, meaning that the consumer is trying to run a SQL, to inject a SQL. That's the SQL injection use case. So we should have something taking care of this kind of situation. That's where the WAF comes in. The AWS WAF comes in. So here's my WAF. I have already created this ACL, but as you can see, the ACL doesn't have any rule defined. There's nothing here. So I'm going to create a very first rule for my WAF ACL. For those not familiar with AWS WAF, there's so many policies you can implement in the WAF layer. Again, the GUI has got some sections. So these are the rules implemented by the AWS WAF itself. But then if you scroll down, you're going to see other rules other companies implement with their own technologies. You can subscribe to them using AWS marketplaces, if you will, and so on and so on. It's a very, very extensive infrastructure taking care of the specific use cases related, of course, to API security. Just to show a very simple implementation, I'm going to turn SQL database rule. That's the guy responsible for identifying SQL injection attacks. So again, I turn that on. I'm going to add to my rule. I'm going to save it. And then we got the rule in place. And then we try to consume it again. We are supposed to get an error code, 401. Who is replying that? The WAF. So the WAF is not routing the request to the gateway, therefore is not hitting your upstream service. So again, the WAF is taking care of the SQL injection use case for us. Makes sense? Last but not least, I just wanted to turn the rate limiting policy again one more time. I'm going to enable that one, and then we try to consume it. one more time. Oh, I'm not able to consume this one because it's got a SQL injection. So if I try to consume this one, I should see some new headers available for me. These headers, they are related to rate limiting policy. So if I keep on sending requests to the data plane, eventually I'm going to get 429, meaning that I have reached the rate limiting policy I have defined for this specific route. One last thing before I stop. I just wanted to scale out the data plane deployment, Kubernetes deployment. Now I'm leveraging this. I'm going to run a very, nothing really Kong related. This is a Kubernetes command. I'm scaling out the Kong data plane deployment, saying that, I want 3 replicas for my deployment. So again, when I do that, I can see 2 new pods coming in, getting started. More than that, if I jump to my control plane, my data plane nodes, they should be connected to my control plane as well. So these pods, as you know, these pods are getting abstracted by the Kubernetes service sitting in front of them. So as a matter of fact, the consumers, they are hitting the Kubernetes service, and then the Kubernetes service is routing the requests to one of these pods sitting behind it. So again, I'm doing it manually using kubectl commands, but as you know, you can make all this, you can implement automation, all this using HPA, horizontal pod autoscaler, for instance. Again, the combination Kubernetes, EKS technologies, and Kong data planes kind of, at the end of the day, provides a very, very, very powerful environment for your API gateway, more precisely data plane. So that concludes my demo here. I'm not sure if you guys have questions, or back to Anuj.
Yep, sure. I don't think there are any pending
questions here. Can these AWS WAF be configured to running as a Docker container? Yeah, absolutely. As I said, Kong, especially data plane, the control plane kind of a stable environment. We are not going to have, of course, you're going to have multiple control planes for each one of the different environments you might have in your organization. So one control plane for development, the second control plane for pre-production, the third for production, and so on and so on and so on. But they are still very stable environment. What really dynamic is the data plane. You're going to deploy your data planes using all sort of platforms, not just Kubernetes. As I said before, EC2s plus auto-scaling group, ECS as well, and so multiple regions. As a matter of fact, some data planes running region number 1, other data planes running region number 2, and so on and so on. That's the way it's going to be, in order to support these multiple environments. And are these configuration for this deployment available in any GitHub? I'm going to do it. We got some documentation in GitHub repos, but I'm going to provide a specific one for these, combining these multiple AWS services, Cognito, WAF, CloudWatch, and so on and so on. And then, of course, Kubernetes for my data plane platform. Absolutely. That's all I have, I believe. Hey, Anuj, back to you.
Yep, awesome. So again, thank you everyone for joining today's webinar. Few call to action that we would recommend is, first and foremost, sign up for Konnect trial for free. This is available from AWS Marketplace as well. And you can explore all the demonstration that Claudio went through today in your own at your own cadence also. Secondly, try out the different samples from EKS blueprints so that we can understand, so that you can go through the use cases that we have built in so far. Or additionally, feel free to open pull requests or issues so that we exactly know your specific requirements, and we are happy to help with it. With that, thank you so much. Looking forward for your feedback, and feel free to reach Claudio or me out if you have any questions for that.
Thanks so very much one more time. Have a great one.
Perfect. Well, Claudio, Anush, thank you both so much for joining us today. This has been really in-depth, and I really hope that our audience has been able to take a lot away from this. Oh, I'm going to have to mute you, Claudio. Sorry. Got a little bit of echo from you. So I really do want to thank both of you for joining us today. It's been such a great program. I would like to remind everyone that our session today has been recorded. So if you'd like to rewatch our program, if you'd like to share with the rest of your team, you will be receiving an email with a link to access the recording on demand. You can also find it living on the DevOps website. Just visit devops.com/webinars and be sure to look in the on-demand section where it will be waiting for you. The two winners of our $25 Amazon gift card drawing are Vin P and Indiaga G. So to our two winners, congratulations. Keep an eye on your email. You'll be receiving an email from myself. If you don't happen to see an email, check your spam folder just in case it happens to be filtered out. I'd like to thank AWS and Kong for sponsoring our program. And to our audience, thank you so much for joining us. We really appreciate your time. And if you have just one extra minute, there is a link pinned to the top of the chat that will take you to a survey. And we would love to hear your feedback, whether it's about today's program or an upcoming topic suggestion. Go ahead and let us know there. Either way, we hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Claudio.
Thanks so very much.